Okay, let's jump right into this explainer. For far too long, attention deficit hyperactivity disorder has been defined entirely by what it allegedly lacks. Well, today we are fundamentally reframing our understanding of the ADHD brain. We're shifting away from judgment and looking at this as a truly fascinating biological curiosity. We're going to dive into the hard science and the data that reveals a completely different picture of how this mind actually works. To understand why this reframe is so deeply necessary, we have to look at the staggering emotional toll of our current approach. Dr. William Dotson, a leading psychiatrist specializing in ADHD, estimates that by the time a kid with ADHD reaches age 12, they have received an estimated 20,000 more negative messages from adults than their peers without ADHD. 20,000! That is a constant daily stream of corrective feedback that just chips away at a person's self-esteem. It ends up building a self-image that is completely centered on not being good enough. And this massive emotional burden comes from trying to force a uniquely wired brain to function in a world and a school system that simply was not designed for it. Which prompts us to ask a really crucial paradigm-shifting question. What if the ADHD brain isn't broken at all? What if it's just running a completely different operating system? Section 1. The interest-based nervous system. To understand the inner workings of this different operating system, we turn back to Dr. Dodson. He coined a concept that reveals a pretty stark contrast. A neurotypical brain operates on an importance-based system. It can be motivated by the sheer importance of a task or the long-term consequences of not doing it. Like, I need to pay this bill or my power gets shut off, right? But the ADHD brain, it is driven almost entirely by personal interest and immediate reward. If the task doesn't spark something internal, the brain simply refuses to engage, no matter how important society says the task is. For the ADHD brain to truly switch on and engage with a task, it requires a very specific concoction. It needs elements from what's known as the pinch framework: passion, interest, novelty, competition, or a sense of hurry and urgency. If a task is mundane and lacks these elements, the ADHD brain isn't making some conscious, stubborn choice to ignore it. It literally lacks the neurological motivation to even begin. Section 2. Starved for dopamine. Let's look at how this builds into the physical neurochemistry, because there's a very real biological reason these brains desperately crave high stimulation. The crucial point here is that the ADHD brain suffers from what is known as reward deficiency syndrome. Basically, it has underactive dopamine pathways and decreased availability of dopamine receptors. Since dopamine is our feel-good neurotransmitter, the chemical that drives motivation and positive reinforcement, a neurotypical brain gets a little hit of it just by finishing a mundane chore. But for the ADHD brain, those ordinary tasks literally lack the chemical payoff required to sustain motivation. It is, quite literally, starved for dopamine. This dopamine starvation, combined with decreased glucose metabolism in the brain's attention center, biologically compels the ADHD brain to self-medicate. It basically sends out a distress signal demanding stimulation. This is exactly why people with ADHD might suddenly crave carbohydrates and sugar, which rapidly convert to glucose and boost dopamine. It's why they might be drawn to high-risk extreme sports or highly controllable video games that deliver constant, predictable reward loops. They aren't just acting out. Their biology is hunting for the fuel it needs to function. Section 3. The sensory overload paradox. But what happens when this understimulated, dopamine-starved brain tries to process the chaotic world around it? Well, a super fascinating recent EEG study published in the journal Frontiers tested adults with ADHD during a purely auditory task. What they found was absolutely incredible. The patients showed enhanced activity in the visual cortex when they were just supposed to be listening. Their brains were literally reallocating attentional resources across sensory modalities. They were experiencing cross-modal activation, basically pulling visual resources to process sounds, which perfectly explains why they can become so easily distracted or overwhelmed by sensory input. Conversely, what happens when the environment finally aligns perfectly with their interests? A 2019 University of Florida study proved that when people with ADHD are engaged in tasks they are genuinely passionate about, they experience intense periods of hyperfocus much more frequently than their neurotypical peers. They don't just focus, they lock in. They live entirely in the zone, tuning out absolutely everything else. Section 4. The evolutionary advantage. So if the ADHD brain is just this chaotic bundle of sensory overload, poor working memory, and dopamine deficits, why did it survive human evolution? Why is it still here?
A 2008 study of the REL people in northern Kenya gives us the proof. Researchers looked at men carrying the DRD4/7R gene variant, a gene strongly linked to ADHD traits like novelty-seeking and impulsivity. They found that men with this gene had a significantly higher body mass index, meaning they were better nourished and thriving in the nomadic group. But in the newly settled agricultural group, men with the exact same gene were undernourished. This perfectly proves that ADHD traits are not inherently flawed. They are an incredible survival advantage, provided they are in the right, highly stimulating environment.
Today, the modern equivalent of that nomadic, fast-paced, risk-taking environment is business and entrepreneurship. And the data backs this up perfectly. While the general adult ADHD diagnosis rate hovers around just 4 to 5%, a 2015 study surveying entrepreneurs found that a staggering 29% reported a lifetime history of ADHD. Their brains are custom-built for the high-stakes, novel, and passionate world of starting a business. We see this operating system harnessed by some of the most highly successful individuals on the planet. Take Michael Phelps, who channeled his relentless, restless energy into the pool to win 23 Olympic gold medals. Or David Neeleman, who founded 5 different commercial airlines, including JetBlue. Neeleman actually credits his ADHD for his success, citing his ability to see patterns that others miss. When placed in the right context, these traits transform from a deficit into a profound gift. Section 5. Hacking the ADHD brain. So how do we successfully run this powerful but incredibly specific operating system in our daily lives? The first and perhaps most immediate biological hack is exercise. Dr. John Rady of Harvard Medical School has extensively researched this. A single session of moderate-intensity aerobic exercise elevates and normalizes dopamine, norepinephrine, and serotonin levels in the brain. This doesn't just make you feel good. For an ADHD brain, it directly treats the neurochemical imbalance, providing a vital 2 to 4 hour window of vastly improved focus and significantly reduced impulsivity. Another incredibly effective science-backed hack is called body doubling. This tackles that complete lack of motivation for mundane tasks. You just pick a quiet, independent partner and work in the same space. You don't even have to interact. By leveraging our mirror neurons and the chameleon effect, our natural unconscious urge to imitate those around us, this simple social presence artificially stimulates the dopamine pathways. It acts just like an external executive function manager. Furthermore, we know the ADHD brain struggles with chronic boredom, which research links directly to poor working memory. To combat this during study or practice, you can use a technique called interleaving. Instead of blocking out time to study just one topic, you mix different topics together. It feels a little harder in the moment, but the novelty keeps the brain engaged. And studies show this interleaved practice yields a massive 43% better performance on delayed long-term memory tests. Ultimately, it's about changing our relationship with the way this brain works. As Dr. John Eastwood wisely notes regarding the chronic boredom often felt in ADHD, rather than trying to instantly cure that boredom or force yourself to meet neurotypical standards, we should actually listen to it. Boredom points to a need for agency. It's a message urging you to align your life in a way that gives fuller expression to who you truly are. So if your brain is biologically built for passion, novelty, and interest, rather than societal importance and routine, how will you redesign your world? I invite you to stop fighting your programming, stop focusing on the deficits. Instead, start optimizing your environment for the brilliant, interest-based operating system you actually have. Thanks for joining me on this explainer, and I'll catch you next time as we continue to break down the science of how we think, learn, and live.